Okay guys, last video we have one last implicit differentiation and two related rates problem. Our implicit differentiation, it's just finding dy dx, and they give us a nice simple problem. 5x cubed equals 2y squared plus 7y. Take the derivative, so on this side it's 15x squared. I did not write the dx because it just goes to 1. Now on this side we're only doing y, so it's 4y dy dx plus 7 dy dx. I factor out my dy dx, so I have dy dx times the 4y plus the 7. Then to solve for dy dx, I just divide by the 4y plus 7. Nice and simple. They ask for it in terms of x and y. Okay, then we go to related rates. It's very similar to implicit differentiation, except we take the derivative with respect to time. So it says evaluate dy dt for, and they give us this lovely function here. Then they give us dx dt, x and y. So they're wanting a number here. So what I do is I take the derivative for the entire function with respect to x and with respect to t. So here I'm gonna have to take the derivative twice. First time I pretend like y is with the coefficient, we're going to take the derivative of x. So it just becomes 4y dx dt, but then I also have to do it in terms of y. So now I'm going to treat 4x as the coefficient and take the derivative of y. So it becomes 4x dy dt, right? Then I have minus 3 dx dt plus 12y squared dy dt. And the derivative of a number is 0. Make it go to 0. Then I plug in everything they give me, the dx dt, the 4, and the 2. You'll see how I plugged it all in. You can pause it if you need to. And I still have 2 dy dt's. So I combine like terms, and then I solve for dy dt. So my dy dt over here, this is 64 dy dt equals negative 88. I divide, and then I simplify, so my answer is dy dt. My y is changing with respect to time at a rate of negative 11 over 8. Then the last one is that area problem. They love it, but it's so simple, so I figured I'd go over it. It's the pond where you throw the rock in the pond, and then the ripple is increasing outwards, right, in a circle. So it says the ripple is increasing at a rate of 3 feet per minute. Find the rate in which the area is changing when the radius is 10 feet. It's this. Area equals pi r squared. Take the derivative of both variables, dA dt equals 2 pi r dr dt. They want to know dA dt, so just plug everything in. 2 pi. What is, the radius is 10, and then dr dt is 3. Sorry. You plug everything in the calculator, and you get 188.496. Okay, guys, just email me any extra questions. I'll have test 4 stuff up tomorrow.